Blueprints in Unreal is a bit like a prefab and a C# script combined into one single asset. So let's create a blueprint. If you go into Window, Content Browser, and Content Browser 1, you can also control space to open this like a temporary content browser, which disappears again when you press control space again. But I like to have it docked permanently. So anyways, to create a blueprint, you just select a folder and right click and select blueprint class. And here you can select which parent class your blueprint is going to have. And I'm just going to pick actor, which is basically anything that exists in your scene. I'm going to call it BP underscore tutorial. And BP underscore is the common, it's like the standard prefix for blueprints. And there's this handy page where you can see all of the common or recommended prefixes for each asset type that I highly recommend just copying. All right, so let's open our blueprint. This may be a little bit confusing at first, but so I mentioned that this is a combination of a prefab and a script. So you have your viewport, which is when you want to work a bit more with your prefab aspect of your blueprint. And then in the event graph, this is where your code lives. So immediately you're going to see the event begin play, which is the equivalent to the start function in Unity. And the tick, which is the equivalent to the update in Unity. So these are events and they live in your event graph. And then you also have functions. So I could make a new function and call it test function. And then in the begin play, I can left click drag this function and then connect these two pins together. So now instead of having to go and find my function here, I can just double click on the node. This will take me to the function itself. And we can right click and look for print string and connect this thing and compile. See, this is one of the things that I love about blueprints compared to C# in Unity, is that the compiling is basically instant. Even with more complicated blueprints, I haven't really noticed any compile time whatsoever. So just like in Unity, you simply drag your prefab or your blueprint into the scene. And if I press play, we'll see that it says hello. To make a variable, you can just click the plus here. And one thing that you can do in blueprints that you can't do in C# or in C++ is you can do this, which I know is going to make a lot of programmers screech in pain. But personally, I think this is more readable. This is of course just a preference, so you can name it in any way you want. Of course. So to change the type, you can just select here. So if you click this drop down over here, you can see that you can change this integer into a single integer, an array, a hash set, or a dictionary, which is called a map inside Unreal. So one of the things I hear programmers say about node-based programming is that it ends up being this spaghetti nightmare. And it can be, but in the same way that you can create terrible, terrible code in a written programming language, the same way you can do terrible blueprints in Unreal. But you can also make organized stuff in Unreal, believe it or not. So when you see this kind of stuff, it's basically the equivalent of someone writing thousands of lines of code in one single function. So this is just really, really bad. So this is not really the fault of using a node-based programming language. This is more the fault of someone not organizing their blueprints. So to address this, there's several things you can do, which is of course, make sure to split up your functions into separate functions, as you would normally do in C# anyways. Another thing you can do is you can group your functions into categories. So now I made this into a category. I can just drag this function under here. And now I have this category of test functions. So one of the things that I typically end up having is, for example, I have this function here, which is called deactivate. There's many things that it has to do. And instead of having this one gigantic mess of nodes everywhere, I started by making all of these functions inside this function, just to figure out how this entire function was going to work out. Once I have something functional, I start to split this function into several functions, and I try to give them names so that I can basically read what this function does almost as if it's written English. So most of these functions are very simple, which is probably a little bit overkill, but honestly, it's been helping me avoiding ending up with anything that looks remotely like this. So for example, this one is a little bit more complicated and a little bit more messy. What can we do to make this more readable? First of all, I like to try to align things. It just makes the whole blueprint just easier to comprehend, in my opinion. This is terrible. These lines going through all your nodes, you can double click on the line to create this extra node that you can then move around and pass the line through a more clean path. It does feel a little bit like there's this extra puzzle that you have to solve with blueprints that you don't really have with C# or C++. Once you get used to it though, you start doing it completely subconsciously. And while I'm thinking about what to do next in my blueprint, I begin to tweak all the nodes and the lines and just start to clean up what I have in front of me, a bit like you're doodling on paper while you're waiting for something. And it doesn't really take that long to get something that is way easier to comprehend. So now that I've cleaned up this function, I still feel like it's maybe a little bit too many nodes for one function. What I think I'm going to do is I'm going to move this over here because it's setting some variables that live in this function. So these local variables, they belong to the save schematic function. And so if I select these and right click and collapse to function, and then I'm just gonna call this collect data. That's a really terrible name, but let's just name it that for now. And now this becomes a little easier to understand. Now these variable names are terrible, so let's call it exactly where it's going. There we go. I'm just going to put that here. And so here's something that might be better with a sequence node. So if I hold S down and left click, I get a sequence node. And this node is really simple. All it does is it executes one thing after the other. And you can add more things that it has to do, and you can right click and remove them again. So right now we're only doing two things. So I'm just going to have 2. And if you alt left click on a connection, you remove the connection. And now I'm going to hopefully have a cleaner graph. All right, so I'm not so sure that this is easier to read, but at least now you know this sequence node exists, and it can be quite handy to organize your stuff, especially if you have a long line of nodes, which can be quite hard to comprehend if it just keeps going. Now you have this weird long graph, which can be pretty confusing to look at. So if that's an issue, the sequence is pretty good to reorganize your code in a more vertical layout. Back in the tutorial blueprint, let's go over the most basic nodes. So if you hold B and left click, you get a branch. So every time I mention a hotkey, you don't have to remember these. You can right click and then search for what you're looking for. So if you type branch, it's just gonna show up here. But I highly recommend trying to memorize these shortcuts because it can really speed up your process when you're creating these nodes over and over again. So obviously the branch is a basic if-else condition. So if I just make a test bool and change it to Boolean and throw it into the graph. Now when you drag into your graph, it's going to ask you if you want to make it a get or a set. So we want to select get and hook that up to the condition. If I compile, now, okay, so this is one thing. If you made your Boolean and you don't see the default value, like if I select this is a variable integer, still don't see that. I guess I haven't compiled at all yet. So if I compile now, right. So now I can set this default value for the integer, and the default value for this bool is true. So when you run this function, it'll check this variable, it'll be true, it'll go this way. To make a variable public, you simply click the eyeball over here. And if you check in your outliner, which is the hierarchy in Unreal, you can select your blueprint and you will see your test bool is now available. So remember those categories I was talking about in the blueprint? Well, if I put this Boolean in the test functions, let me just rename this category to tutorial. Now we have a category that's called tutorial, and I want this variable, in fact I want both these variables to be in the tutorial category, and I can do that by selecting here. And once I have one of them, I can just drag the other into the category. So if I compile now, I should be able to see that the category is called tutorial, and I can see all the variables that are public. We can see a whole bunch of other variables, but that's because we made our class a child class of the actor class, which by default has a whole bunch of variables that you can tweak. One thing you can do in Blueprints, which is pretty handy for testing, is if you select one of your functions and enable call in editor, compile, and now you get this button. So when you press this button, it's going to execute this function, which right now is not really doing anything. So if you hover over one of the pins and you left click drag, it'll automatically open up this search thing. So you can look for print string and test function and compile. And this will only happen if this is true. So let's give that a try. So this is false. Nothing's happening. This is true. Nothing's happening. Why is that? That's because, right, so it's not working because we changed another test function. So terrible names, by the way. I need to work on my tutorial function names. Nothing happens now. But if you look at your blueprint, you will see this line is animated, telling you that the code got to here and didn't get any further. So if we drag out and write print string, and this is working, and compile, and I press the button, and it's working, but you're not seeing any print value, and that's because it's showing up in your output log. The text that you see in your scene is for play mode. So if we go into play mode and we select the tutorial and press the button, now you can see the text. To make a for loop, you can press F and left click. You can, of course, also create a normal for loop, and you can also create them with a break. So if we do like this, and if this is true, then we break. We can loop this all the way around. So I'll go through this loop 10 times. And if this is true, then I'll stop the loop. And once it breaks, then I'll go here, and then you can do something else here. You can, of course, create a subclass of your class. If you just right click on your class and create child blueprint class, or if you create a new blueprint, I should be able to write bp_tutorial, and here it is. So one concept in blueprints, which is a little bit different than prefabs, is that there isn't really game objects in the same way. I mean, I guess the actor class is kind of a game object, but in Unity you have a lot of game objects, and you would typically, nest them and have a whole hierarchy of game objects. You don't typically do that in Unreal. Instead, you would typically just have components. For things that have a more complicated hierarchy, like a skeleton, you actually have a skeletal asset. So if we open this skeletal asset, this is where all the joints exist, and they aren't really the same as game objects because it's its own, asset. So if I put this character in the scene, you'll see there is no game objects for every joint or anything like that. It's just one object. So basically the point was just that the game objects in Unreal, they do exist in the form of actors, but it's much less a core concept of Unreal than it is in Unity, I feel. You can also make what is equivalent to C# interfaces. If you right click and the blueprint, select blueprint interface and call it BPI_, and I just can't think of any other name right now, so it's just going to be tutorial interface. And if you open your blueprint class, and here under class defaults, it's class settings, then if you go to here and type in BPI, yes, here it is. And now you have this interface implemented. Now this interface doesn't have any functions yet, so nothing really happened. So let's open this and let's call it, oh god, what are we going to call it? Yet another tutorial function. Yay. Back in the blueprint class, if we compile, I believe, then under, where is it? Interesting. What did I forget? Compile? Interfaces. Here we go. So now we have this function implemented from the interface. And if I select the interface, add some kind of variable, compile, now it shows up here. Static functions is also possible with blueprints, but a little bit more janky in my opinion. So if you right click and blueprint, and Blueprint function library. And I typically just call it BPF. And then, oh god. Sorry. Functions. Great. So if we open this, another function, but it's static this time. All right. And in the Blueprint, now we can right click and what did I call it? Create another function, but it's static this time. There we go. So I guess in compared to C#, where you would have a static function inside one of your classes, this is kind of like a global function. So any of the Blueprint functions that you create in this library asset will show up in any Blueprint. If you just right click, it'll show up here. Here's some more organization tips. If you select a bunch of nodes, you can press C. This will create a comment box and write something descriptive. And you can of course scale it. And one handy thing is that you can move the entire thing, and this will move the whole thing, all of the nodes inside of it. You can also, as you can see here, you can set a comment for each node individually. So if you hover above the top left area of a node, you'll see these tiny dots. If you click on them, you can write some other stuff here. There's some other stuff. So this can also help organize your stuff. You can also, if you select your comment box, you can select another color. It's a nice pink color. I don't generally use these because as soon as I feel like I need to explain something, I feel like to me it means that it's too complicated and there's too many nodes. I should probably split it up into more functions. I would rather have 100 smaller functions that are super easy to understand than only have 20 functions and half of them are like super confusing. So generally I like to keep my functions to only fill this space. I don't want to have to drag around and figure out what's going on all the way over here and then drag around and, oh, okay, it's connected to this thing, and it just becomes very confusing very fast. I would recommend this approach. It's been working very nicely for me at least. Another neat little trick is if you have, for example, let's say you have a bunch of nodes that are connecting the same pin, and all of a sudden you realize that you maybe have another, let's just say you have another bool, right? And you want this bool to be the one that it's referencing. And instead of having to, you know, do this, which is kind of a pain, you could do that, of course. But if you control click on this pin, you can move the entire thing and reconnect it like this. You can also directly drag a variable onto a pin, and this will automatically connect it. You can also control click drag on a variable to get the variable, and you can alt click the variable to set the variable. So for debugging, I've already shown you how to print on screen, and this will print on screen, but it will also print in your output log. So it's basically the same as debug.log in Unity. If you select a node and press F9, then you get this red dot. And if you compile and run, and we select the tutorial, and so this was another test function. If I press this, then the game pauses, and this functions like a breakpoint. So you can see that it got to here and it stopped. And even without breakpoints, having the Blueprint opened while you press this button, you'll be able to see how the logic is going around. And if I turn this off, how is this going over here? Huh? All right, I had to compile, of course. Another thing you can do is if you drag this here and you press play, and so you can hover your mouse over a variable to see what the value is at this moment. And you can also right click on the node and click watch this value. And then you won't have to hover your mouse, you'll just see that it's false while you watch what's going on in the game. So it's set to true now. And if I set it to false, you see that it's set to false. So you'll be able to see live how your values are being manipulated. You can, of course, see what the values are just by selecting the object in the scene and see, you know, what the values are set to here, just like in Unity. I think I'm going to wrap this up now, and I hope this was useful for you. Of course, this doesn't cover every single aspect of switching from C# to Blueprints. Hopefully, I will find the time to make more of these and help you switch from C# to Blueprints. Goodbye.